Hello and welcome back to Calculus 2 section 7.1 on exponential and logarithmic functions. In the book they say revisited. Well, we are visiting them for the first time in Calc 2, so I'll want to skip on that word. Exponential function is the only function that remains the same as you apply the derivative and integral, right? So we want to expand a little bit on it and add some more formulas. So let's start by first writing down the formula integral e to... No, let's start with the derivative. Derivative of e to the x is e to the x, right? Then what you did is you said, well, chain rule. So you get to write the formula that you use 99% of the time. The derivative in respect to x of e to the f of x. So now it's not just linear function y equal x in the exponent. It's any function you can think of. Sine x, right? Or x squared minus 7, any function. And the derivative was e to the f of x times f prime of x. That's your basic chain rule. Stuff you know from Calc 1. And I'll say 99% of the problems live here. Right? That's it. But that's not the general form, because your base is fixed to be e. E is a very specific constant, about 2.7, right? So what if the base is 3? What if the base is a half? How about the negative 5? How about the positive 17, right? So we get the general case, which you pretty much never use because the nature lines itself up on the e. General case is the derivative of b raised to f of x. Now you're allowed to have any value in the base and any function in the exponent. You cannot have more general, right? You can't have more general case than this. And that one is, again, the same story. Control C, Control V, times the derivative, and finally times the ln of the base. So that's your exponential derivative. And you're done. So we covered and finished the derivatives of exponential functions. Now again, as I said, the boss is the one on top because most of your sciences and courses and everything will have e in it, not 3 and 7. Now, yes, there's going to be a base 10 here and there. So that's why I said 99% of the cases. pH calculations in chemistry use base 10. Earthquake calculations in physics use base 10, right? So waves. So you are going to run into base 10, but vast majority of them is E. So yeah, the red formula with the black case is what you need. But let's do the example for this. So what is the derivative of 8 raised to the sine x? This is on your first exam. I am going to ask the formula you are never going to use, because the other formula is going to be included in other stuff anyway. So what do I do? Control C, Control V. So 8 sine x times the derivative of exponent sine x is cosine x times ln 8. And just walk away. That's it. That's all you need to do. Now some of you say, can I put ln in front because it's constant? Yes, ln 8 is constant. You can punch that in a calculator and get decimals if you care. We don't care. Leave it ln 8, right? You don't have to waste more of your life on this problem. Guys, that's exponential derivatives. How about exponential integrals? Same deal. We start with the integral e to the x dx is e to the x plus c. That's your 4.9. And then you finally reach the point where you can say, oh, in 5.5 we learned the chain rule, backwards chain rule, which is u sub, where you get your most common e to the f of x dx. And that one would be what? Oh, oops. E to the f of x times f prime of x. Holy nightmare. Bad day. Is going to be e to the f of x plus c. So this is your u sub (5.5) from Calc 1, and most of your examples are right there. We don't even bother with the base 10 or any other base. So integral of x e to the x squared plus 1 dx, you are using u equals x squared plus 1, du equals 2x dx, right? And now you need the 2, so you add in the 2 and the half in front to fix it. It's a 1/2 integral of e to the u du, which is the basic integral up there. So 1/2 e to the u plus c. I don't care about u, I care about the x, right? So 1/2 e x squared plus 1 plus c, and off you go. Now, very frequently, I'm going to write this formula also in red. Very frequently, you see that formula with a, when it's just a constant. It's not the full function, so you have to really crank. U sub integral e to the ax dx is e to the ax over a plus c. This formula falls under the formula with f of x, but it's so easy to remember that you really don't have to, right? So you're going to have a lot of these as well. E to the 3x, e to the 6x, and stuff like that. Put that one on the cloud. A is a constant. And such is life. There we go. We are done with exponential functions. That's it. That's all we want to know. You want to know limits, but you look at the graph. Well, that would be worth writing, right? Just in case. It's not a part over there in the book, but whatever. Limit of e to the x as x goes to infinity is infinity, because, right, the y value goes to infinity. Limit x goes to negative infinity of e to the x is 0, because it goes to the other side now. And decay would just flip them, right? So limit x goes to infinity for e to the negative x would give you 0. So as you go to infinity, you see that the y value drops down to 0. And finally, limit x goes to negative infinity for e to the negative x is infinity, because negative infinity is this way and the y value shoots there. Cool. That's the limits on E, and now we can move on to logs. Exactly. So,
go back up for a second. A minute, please.
oh, sure. I have to be more specific.
Yeah.
I'm a mathematician. Everything has to be, yeah. Go up for a second. So, logarithmic function, right, is the inverse of exponential function. But before we, I usually like to talk a little bit more about it before we jump into the formulas, because people generally don't like logs because they don't understand what they are. So before we go into logs and all of these kind of things, I'm just going to ask some math questions that you might know. 2 plus 3 is, and then 5 minus 3 is, and 5 minus 2 is, beautiful. 2 times 3 is, and 6 divided by 3 is, and 6 divided by 2 is. You see what I'm doing? I'm using the operation, and then I undo that operation with the opposite operation, and I'm able to recover 2 and 3, which created 5. Same happens over there with multiplication and 6. I'm able to recall, right, 2 and 3 by using division. Now, multiplication is fast repeated addition, right? Now we go with exponents. 2 cubed is equal to 8, because 2 times 2 is 4 times 2 is 8. When you multiply 3 2's together, you get 8, right? So how do I recover a 2? Well, clearly, cube root of 8 is 2. How do I recover 3? Yes. Yes. Log base 2 of 8 is 3. That's where it fits in mathematical family. It is mathematical operation. So in the way where you combine 2 and 8 using a log, you get 3. Now, why do you hate it? Why do you discriminate against it? Because it has letters, right? It's not a cute symbol. It's letters, and obviously you immediately just say, no, right?
I don't like letters in my math.
Yeah. So, log is operation. Log is not a function until you stick an x in there. It's not a function. When you stick an x inside, then it becomes a function. You see, 2 plus 3 is not a function until you say x plus 3. Oh, then it's a linear function, right? Cool. Your 6 divided by 3 is not a function until you say x divided by 3 or 3 divided by, or 6 divided by x, right? It becomes rational function. Your 2 to the 3 is 8, but then 2 to the x is exponential function, right? So your log becomes a function when you stick x inside. Before that, it's just a calculation. You punch some numbers on the calculator, you get a value. So just like 2 plus 3 is 5, log 2 of 8 is 3. Log base 10 of 1,000 is a 3. Log base 10 of 1,000,000 is 6, because 10 to the 6 is 1,000,000. The most important formula to learn between the two worlds is a conversion formula that moves one world to another so you can solve equations. And that world is a raised to the b equals c converts into log base a of c is b. This is the most important formula of logs, because this formula is the one that converts one world into another world. And this is also where we see that they're inverses of each other and all of those good things. Now, what is ln? Well, log a of c. A is allowed to be any number. Our example up there, our base was 2, so log base 2 of 8 was 3. I gave you the log of 10 of 1,000 was also 3, right? When that a is a special number e, then the log becomes ln. So the next formula, let's go blue, log base e of x is called ln x. Please note, it's just a lazy notation. We are cutting out, instead of writing 5 letters, we are writing 3. It's called efficiency in mathematics, all right? So I don't care if you're going to use log base c or ln, right? It means the same thing. Another one of those shorthand things is log base 10 of x, which is just called log x. We are again cutting out 2 characters, shortening our notation, right? 10 has 2 digits, so 2 characters less to write. On your TI-8384 calculator, which is what most people are using, or if you, right, are able to upgrade or ready to upgrade, right, to a real phone from the garbage that you're probably using, you can do that, right? The TI calculators are using ln button and log button, and these calculators do not have base 7 and base 5 and so on. Now, you can still calculate those bases using change of base formula. Where you take log of any base of b and you write it as ln b over ln a. You can also use log b of log a. So you are still able to calculate any base in your calculator, even if you don't have the button that allows you to enter base 3, if you know the formula for change of base. The next 2 formulas for logs I call cute formulas, because they are helping us plow through calculations quick. Log of any base of 1 is 0. That includes when a is e, which is ln. So ln of 1 is 0 as well, right? So log of any base of 1 is always a 0. Why? Well, here's why. Because a to the 0 is 1. If you do the conversion formula from the top, right? And the second cute formula is log a of a is always 1. That one you can also just say a raised to the first power is equal to a, right? If you use the conversion formula to show. So these are your 3 formulas. Sorry, these are your, so far, 4 formulas. You have a conversion and these 3. And then that's just, guys, this is just names, right? Calling names. Those are not formulas. That's a formula. Those are formulas. Conversion is a formula up there. And finally, to complete your ln world, the three formulas that we had in Calc 1, which is log base A of x times y is log ax plus log a y. Log ax over y is log ax minus log a y. And finally, log a of x to the p is p log a x. Those are the three formulas which we used for logarithmic differentiation in Calc 1. And these formulas are even proved through integrals in the book if you open it, but we just don't worry about it. Now that you know your pre-calculus for logs, right, we can finally go ahead and write the derivative and integral formulas and be done with 7.1. So let's take a look at the derivative of ln x. Help me over here. Derivative of ln x is 1 over x. Awesome. How often do you see this? Almost never, right? It's the red formula that you are waiting for. ln of f of x, where you get to use the chain rule. So the red formula is the one that will be pretty much always in use, which is simply the derivative divided by the original function. This is the one. If you are looking for a tattoo, that one. Yes, I cannot ask you to remove it for the exam. You would be able to cheat. But it has to be permanent ink.
Yes.
None of that stuff that washes in a, you know.
What if it's the stuff that you can get it removed with the
Or a hacksaw or something. Yeah, I know what you mean. All right, good. All right. Is this the end of the story? Obviously not. We have the general case when we say log base b of f of x. So now it's not just base e, it's base 7, it's base 13, right? So anything that you can possibly think of. And in this case, we are going to have the ln b drop out. So we still have our f prime of x divided by f of x, and it's just going to stick this ln b in the denominator as well. So this is your general case, the Boss equation. But then again, right? Who uses this? So derivative of log base 6 of cosine x. Yes.
I think the stream dropped.
Uh-oh. No, it's showing that it's actually going really strong over here.
Okay.
Maybe try refreshing the page, see if it helps. Thank you, though. Control C, Control D in the denominator. The derivative of cosine is? Nah. Negative sign. And then we also have ln 6. Did it work?
It's working on hers, not on mine. That's fine.
That's concerning because you are using the real computer. All right. Everyone is looking like, yes, exactly what I am. negative tangent x over ln 6. In this case, any function goes instead of the cosine, right? Exponential function, another logarithmic function, any trig, even the functions you're going to learn on Thursday, like anything goes there. Finally, we reach integration. Integral of 1 over x dx is ln. Now we're talking. Absolute value of x plus c. Now, you have seen a lot of, you are going to see a lot of these. Some number a divided by x minus b dx. You're going to see a lot of this in chapter 8. And then differential equations, all right? So, quickly, you can just say, oh, that's a ln x minus b plus c. If you are not remembering this now, trust me, it will kick in chapter 8, called survival instinct. And the formula that we all care about, which is the u sub integral f prime of x over f of x dx is equal to ln of absolute f of x plus c. This is the boss. And technically, that's your u sub. That's your u sub. Quickest, maybe best example is the integral of tangent x dx. Tangent x is not the basic integral, right? It's a composite, it's a u sub, because you have to write this as integral of sine x over cosine x dx, and then you have to run the u sub, but you can see it's in this form, and you can solve the integral of tangent x using the u sub, right? This, I know I lectured on this in my Calc 1 class. Not everyone does, so some of you might not know the way to get the tangent. It's not a basic integral. It's a basic derivative, but it's not a basic integral, right? So we have u equal cosine x, du equal negative sine x dx. Now I need those negatives. Put those in. This is equal to negative integral of du over u, which is negative ln of absolute u plus c. Then you plug in a cosine in there, negative ln of absolute cosine x plus c. Now, you might be tempted to leave it this way. Don't. Because cosine and tangent are not paired. What's a tangent paired with in calculus? Nope. Secant. I heard it. Secant. Sine is paired with cosine, tangent with secant, and cotangent with cosecant. Why? Because derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, right? Derivative of secant is secant tangent. You see? It's always secants with tangents. So you can't leave integral of tangent as a cosine. But hold on. Didn't we just cover this formula? What is p in front of the log can jump in as the exponent? What's the value of p in this answer? And what's negative 1 going to do to a cosine? Put it at the bottom, make it 1 over cosine. And 1 over cosine is secant. Yeah. So, ln of absolute cosine x raised to negative 1. Be very careful how you write this. Do not put cosine negative 1. What's cosine negative 1? That's inverse cosine, right? So, this is ln of 1 over cosine x plus c. And there's your ln of secant. ln of secant x plus c. Now we're talking. And you don't memorize it as a I mean, you can if you want to, but integral of tangent is ln of a secant, right? Not a basic integral done through sub right there. Of course, math. That's it. We're done. 7-1 finished. What you need to do is just 100,000 of these problems to just get these formulas down if you don't know them from Calc 1. The formulas where we added the base b are the new ones, right? So you practice those. The other ones you were supposed to know from Calc 1. If you don't know them, cool. Here's the refresher. And let's take a short break and then go with 7-2.